This lesson is on solving quadratic equations. Quadratic equations are equations that have squares on the variables. You will find this to be a good use for using the factoring skills that you have learned up till now. Let's first consider the zero property. The zero property considers what happens when two numbers multiply to give zero. What can you recall about the numbers when something equals 0? Well, what's an example? 2 times 0 equals 0, 3 times 0 equals 0, 5 times 0 equals 0, and so on. 0 could be in any position and it would give you 0. Even if you had three numbers multiplied together, 2 times 3 times blank would give you 0. Well, the only way to multiply three numbers is to have at least one of them be 0 in order to give the answer of 0. So you can see that if you have a times b giving you 0, then you know for sure that either a equals 0 or b equals 0. So let's take a look at quadratic equations. A quadratic equation is any equation that can be written in the form of ax squared plus bx plus c equals 0, where these are the coefficients. A, b, c are in the real numbers and a is a non-zero number. If it was 0, then you'd have a regular equation with no squares in it. So, like I said at the beginning, a quadratic equation is essentially an equation that has squares on the variable. Let's take an example. Say you had x squared minus 10x minus 11 equals 0. We can no longer solve this in the regular fashion where we isolate x on one side, because now we have an x squared and an x, and those two do not combine. So, what we can do is we can make sure that you have everything on one side equal to 0 in standard form, like so. We know that when things are equal to 0, especially if we could factor this and put it into some sort of factors where you have something times something equals 0, we know that either this factor equals 0 or this factor equals 0, which comes from the zero property. So it's very important that you have that one side equal to 0, because that property does not work for any other number. You can't say that if something times something equals 1, then one of those things is definitely a 1. There's no telling about that, right? You could have 1 times 1, but you could have 2 times a half, for example. So my point here is make sure that you have everything on the left or the right, but the other side is always equal to 0. The next step is to factor the one side completely. We have done this before. We've learned how to factor over the last few lessons. So let's take a look at how to factor this example. Here we have a leading coefficient of 1, meaning we can directly factor and find the sum of the two numbers to be -10 and the product to be -11. So we have x. Two numbers that multiply to -11 would be either 1 times 11 or that's it. And we need a difference of 10. It's perfect. So we need -11 plus 1. So let's check that. -11 plus 1 is -10. -11 times 1 is -11. Great. We have factored completely. Next, we can use the zero property to break up our equation into smaller equations that we can solve. Because we factored, we now have the product. Remember, the zero property states that if you have things multiplied to equal to 0, then you know that one of them is 0. So either x minus 11 would equal 0 or x plus 1 would equal 0. This will give us two possibilities, and that's better than an infinite number of possibilities. At least we're narrowing it down to possible numbers, and we can always check them back into the equation and see if they work. Okay, so what comes out of what would x have to be if x minus 11 equals 0? Well, we can just solve it like a regular equation, add 11 to both sides, and we get x equals 11. Now check that. If you plugged it in here, 11 minus 11 would give this bracket to be 0. 0 times whatever this is will be 0. I don't even care what this is. So it technically would have been 0 times 11 plus 1, which is 12. 0 times 12 is 0. Great. So x equals 11 works. What do we get from the next bracket? X plus 1 equals 0, so minus 1 from both sides, you get x equals negative 1. Same thing. If you stuck a negative 1 in, you'd have 0 times negative 12 would also give you 0. So we've found two answers, x equals 11 or negative 1. You always want to check your final answers in the original equation to double check if they work. You can do so by opening little brackets and filling in the numbers. So please take a moment and check if those answers work. Here's some more examples. So we need to solve. So we want to have everything equal to 0 first. Very important. Next, we want to factor what we've got. Remember, in our factoring strategy, we want to first take out any greatest common factors possible. In this case, x is a greatest common factor, and you're left with 5x plus 7 equals 0. Hey, that's all we needed to factor. Great. You want to make sure it's factored completely, and that every single factor which multiplies together to 0 will be considered as a separate equation, because if x was 0, it would make the equation true. If x was something that made 5x plus 7 0, then it would make the equation true. So we're using the 0 property here. If x equals 0, that's it. That's one option. Or 5x plus 7 could be 0. So let's solve that. Minus 7 from both sides, you get 5x equals negative 7. Divide by 5 on both sides, you get x to be negative 7/5. That's the other option. So you have two options. X is either 0 or negative 7/5. You can check your work, plug it back in, and see if they work. 5 times 0 squared plus 7 times 0, yes, that equals 0. If we put in negative 7/5, you have to use your fraction knowledge a little bit here. So you got 5 times 49 over 25 plus 7 over 1 times negative 7 over 5, and I'll just make this here negative. So you could go through that and check it out. The 5 cancels with the 25. So we've got both denominators equaling 5, and 7 times 7 here. So we've got 49/5 minus 49/5. And check that. That works. Both those answers work. So both of these answers are solutions to this equation. Let's check the next one. We need to make sure that we have this property of equaling to 0, because that's the only way we can split it up into smaller pieces using the 0 property. So let's get everything on one side with decreasing exponential order. So x cubed plus 7x squared, we're going to add 6x to both sides equals 0. And notice we want decreasing exponential order, and we have that. 3, 2, 1. Great. Is there a greatest common factor? Is the first question we ask when we're factoring. Yes, there is. We can take out an x, leaves us with x squared plus 7x plus 6 equals 0. That's not quite factored completely because this is a trinomial. Leading coefficient 1 means that we can directly factor. We don't need to decompose in this case. But if we had a number here, you would decompose and factor completely. So we know that x times x will give us the x squared. We want two numbers that have a product of 6 and a sum of 7. So that would be either 1 times 6, 2 times 3. They have to add to 7, so 1 and 6 works. 1 and 6, positive, positive. Let's check that. Positive 1 times positive 6 is 6. 1 plus 6 is 7. Great. You can always double check by expanding if you'd like. Okay, I think this is as far as we can go with our factoring. So we can now apply the zero property. The zero property allows us to say that one of these could be 0 to give us a solution. You'll also notice that when your degree is a certain number, that will indicate the maximum number of solutions you will have. So because this was a degree 3, you're going to have 3 possible solutions. This was of degree 2, you had 2 possible solutions. Recall when you had just a basic equation with degree 1, you always had 1 solution. So that is another thing you can notice. Okay, so x equals 0, or x plus 1 equals 0, or x plus 6 equals 0. X equals 0, sure, if you plug that in, it would make it 0, great. Take away 1, you get x equals negative 1. You could plug that in, and that would make the middle term 0, times the others would still give you 0, and minus 6, you could give x to be negative 6. So the final answer would be x equals 0, negative 1, or negative 6. We have 3 solutions for a degree 3 polynomial. You can also check the answers. Let's continue. These ones are a little more complex because we need to first simplify them to be equal to 0 and then factor and then use the 0 property. So let's distribute here. We're going to have negative 4 equals 9x squared minus 12x. We want everything on one side, so I'm just going to add the 4 to both sides, so that we have 0 equals 9x squared minus 12x plus 4. Okay, so we need to factor this guy here. Now, remember with your factoring properties, you first look for a greatest common factor. Don't have one of those. Next, we consider how many terms we have. Well, we have 3 terms, so it's a trinomial. Under the trinomial category, we had 3 different ways of factoring. Obviously, the last one was the decomposition, which works for any trinomial, but let's see if we can take a shortcut on this. So you could decompose the middle term because of the leading coefficient being other than 1. However, I think there was a shortcut where if the first and last term were perfect squares, you could notice the perfect square formula, which was a plus or minus b squared equals a squared plus or minus 2ab, because the middle terms added up together when you distributed the brackets, plus b squared. If you don't recall that, look back to special factoring. So let's notice, is the first term a perfect square? Yes, it is. Last term? Yes, it is. The first term would have to be 3x squared to give us 9x squared, and the last term would have to be 2 squared to give us 4. So the middle term would have to be double 3x times 2. And is that true? 2 times 3x times 2 is 6 times 2 is 12. And we could just have the negative version of this. Great. Therefore, this will be equal to a, which is 3x, minus 2 all squared. So you could use decomposition on this, but this is taking the special factoring shortcut. Okay, now remember the square means that you will have the same bracket multiplied by itself twice. You can notice that either 3x minus 2 would have to be 0, or 3x minus 2 would have to be 0, so you really only have one thing to solve here. So add 2 to both sides, you get 3x equals 2, and you get x equals 2/3 when you divide both sides by 3. So we have one solution, and we can plug it back in to check if we'd like. And you can check that for yourself. You'll get 2/3 times, and 9 times 2/3 will be 6 minus 12. -4 equals 2/3 -6 cancels. So that should be -4 equals -4. Great, it checks. It's always good to check your answers because sometimes you will find, especially in certain cases, it might not work. Most of the time it will though. Let's continue. Let's first expand everything here. So we got x cubed plus 10x squared equals 2x squared minus 16x. So remember to try these before I complete them so that you can see if you know how to do it yourself. Alright, let's continue. Let's put everything on one side. So let's subtract the 2x squared and add the 16x. So we'll get x cubed, subtract the 2x squared, will give you positive 8x squared, and then add the 16x equals 0. You always want it equals 0 because of the 0 property, which allows us to split it up. Alright, let's take the greatest common factor out, which is x. Leaves us x squared plus 8x plus 16 equals 0. Now we want to factor this. Note that our leading coefficient is 1. Therefore, we could just do direct factoring, but also we have a perfect square. So you can further notice that this is part of the perfect square formula, where now our a would have to be x and our b would have to be 4. And let's check the middle terms. 2x times 4, does that give us 8x? Yes, it does, and it's the plus version. So it's the plus version, x plus 4 squared. Another special factoring example for you. Remember that it's a trinomial, so you could do decomposition the longest way. You could do the direct two bracket way. Two numbers that multiply to 16 and add to 8 are 4 and 4. Either way, you get to the same thing. So again, you take each factor and consider equaling to 0. If it's squared, you only have to consider it once. So it's either x equals 0 or x plus 4 equals 0 that would potentially make this equation true. So x equals 0 is one answer, and subtract 4 from both sides, you get x equals -4. It should be the other answer. You can check both. If you plug in a 0, you can think through this on your own. This would be 0 times whatever. Would this make the left side equal 0? And this side also would have a factor of 0, which would make this side 0. So 0 works. A -4, -4 squared would give us 16, and then -4 plus 10 would give us 6. and 2 times negative 4, and negative 4 minus 8. You can just check this on your own. 16 times 6 is 96, and 2 times negative 4 is negative 8, times negative 12 gives us 96. So that one works as well. So therefore x is either 0 or negative 4. We could also have an example that relates to formulas such as the Pythagorean theorem. Recall the Pythagorean theorem. When you have a right-angled triangle with hypotenuse C and legs A and B, hypotenuse being the longest side across from the 90, we know that the two shorter sides, the two legs squared and added, give us the longest side squared. A squared plus B squared is C squared. This has been used in the past. So, this is an example of an application of using solving quadratic equations. You'll notice these squares will potentially form a quadratic equation, which will need all the things we've learned in the past, such as factoring, expanding, etc., in order to solve something like the following. Find the area of a right triangle that has one leg 7 centimeters longer than the other leg. So let's say A, this leg A, is 7 longer than B, so it's B plus 7. So B is just B. And the hypotenuse is 9 centimeters longer than the shorter leg. The hypotenuse is 9 more than the shorter. Which one's shorter? Well, B would be shorter because it doesn't have a 7 attached to it. So the hypotenuse is 9 more than the shorter leg. So we can see that we have B plus 7 and B as legs and B plus 9 as the hypotenuse. They want the area, but in order to find the area, we need to have the lengths of the sides. So we need to have B, which is our height in this case. So maybe we can use our Pythagorean theorem to our advantage. In order to find B, we could relate all three of these sides as A squared, which is B plus 7, plus B squared equals C squared, which is the longest one squared. Alright, let's continue. We want to expand everything. So recall that if you expanded the perfect square trinomial, you could use the special formula, or you could make two brackets and open it up. You'll get B squared plus twice B times 7 is 14B plus 7 squared, 49, plus B squared. And similarly, we expand the B plus 9 all squared, giving us B squared plus 18B plus 81. We want to get everything to one side so that it equals 0 so that we can use the 0 property. So, you can do this a little bit slower, but I'm going to just look at all the B squares first. We're going to have B squared plus B squared, but then minus B squared. So that just leaves us with a B squared. So I've dealt with the B squareds. Then we have 14B, and then minus 18B gives us negative 4B. And we have 49 minus 81, giving us negative 32. We can now factor this. Notice that there is no leading coefficient. This is not a perfect square, so we can use the direct trinomial factorization method. Our product is negative 32 and our sum is negative 4. We want to find two numbers such that they multiply to 32 and have a difference of 4, so we need to keep going up. Let's see here. 4 goes in 8 times. Oh, that's got a difference of 4. So we can use negative 8 plus 4, so that negative 8 plus 4 gives us negative 4. Negative 8 times 4 gives us negative 32. Now we can consider either b minus 8 equals 0 or b plus 4 equals 0 using the 0 property. Therefore, b would equal 8 or negative 4. Now, Can it be 8 and can it be negative 4? It could potentially be 8. That would give us 8 and 15 and 17. But negative 4 wouldn't work because negative 4 is not a length. So you reject the negative 4 because it's not a length. Great, so we have a triangle now where b is 8, b plus 7 is 15, and b plus 9 is 17. We can now find the area by going half base times height, which is 60. Square units, in this case it was centimeters, so centimeters squared.